Let's now turn to the factoring of ax squared plus bx plus c, both over the real numbers and over the complex plane under two different conditions. First, let's do the condition where the discriminant b squared minus 4ac is not negative. Well, we know that the roots of the quadratic equation are going to be negative b plus or minus square root of b squared minus 4ac divided by 2a. According to the quadratic formula, if I set f of x equal to 0, then x would be equal to one of these two roots. And so therefore, according to the unique factorization theorem, we can write f of x is equal to, well, the constant in front would be the a. Then we'd have x minus the first root, negative b, plus square root of b squared minus 4ac, all divided by 2a. Then this gets multiplied by x minus the other root, which is negative b minus square root of b squared minus 4ac over 2a. And this can be simplified slightly, so let me distribute the negative sign. So x plus b minus square root of b squared minus 4ac over 2a times x plus b plus square root of b squared minus 4ac over 2a. And so this would be the answer to the first problem. And this is the factorization over the complex plane by the unique factorization theorem. And it is also the factorization over the real numbers. By that I mean b squared minus 4ac is not negative, and so we're guaranteed that all of the numbers that appear here are real numbers. There's no square root of negative numbers that appear in the expression that's on the screen here. So that is your answer to the first part. Factor the quadratic polynomial over the real numbers and the complex numbers. There's your answer, and it's the same factorization for both the complex numbers as well as for the real numbers. For the second part, it's a little bit more interesting. Factor ax squared plus bx plus c over the real numbers and over the complex numbers. Now, we still have this expression, but if we have that b squared minus 4ac is negative, then the thing under the square root is negative. And so we can write this as a times x plus b minus I times the square root of 4ac minus b squared. So I basically factor negative 1 out of the square root, and the square root of negative 1 is I, divided by 2a. And then x plus b plus I square root of 4ac minus b squared over 2a. And this would be the factorization over the complex plane. Permitting complex numbers, I have a linear factorization, and I've explicitly written the imaginary part out. Not surprisingly, we get conjugate roots, complex conjugate roots as two of the roots because a, b, and c, they're not written, but they're assumed to be real numbers. Okay, now to factor this over the real numbers, I'll give you a second to think about that. You might want to pause the video here to think about it, how to get the factorization of the real numbers. So I'll give you a chance to pause. The answer is going to be basically where we started from, ax squared plus bx plus c. And you may wish to factor out the a in front to make it a monic irreducible polynomial. But if you were to multiply these two terms in green together, they would form exactly that, x squared plus b over ax plus c over a. And I'll leave that for you as an exercise to check that if you multiply these two things together, you indeed do get x squared, x times x gives me x squared, plus ba times x plus c over a. So that's the factorization of the polynomial ax squared plus bx plus c under the assumptions that b squared minus 4ac is not negative, and under the assumption that b squared minus 4ac is negative.